Enzymes are molecules that increase the rate of biochemical processes, and almost all enzymes are proteins. Today, we will look at 10 enzymes that make possible the 10 steps in the breakdown of sugar. This process is called glycolysis. Hexokinase captures a glucose molecule in its active site, and glucose 6-phosphate and ADP come out. This enzyme is phosphoglucose isomerase. It takes the glucose 6-phosphate and shuffles a few atoms and makes fructose 6-phosphate, phosphofructokinase. It captures the molecule we just made, as well as another ATP molecule, producing fructose 1,6-biphosphate. This molecule is fructose 1,6-biphosphate aldolase, and it cuts the molecule in the middle, producing two similar pieces. Triose phosphate isomerase will change the shape of one of the pieces to be identical with the other, and we end up with two molecules of glyceraldehyde 3-phosphate. Glyceraldehyde 3-phosphate dehydrogenase is another enzyme with multiple subunits. It will add one more phosphate to each glyceraldehyde phosphate. Phosphoglycerate kinase takes each of these molecules and transfers one of each of their phosphates to a pair of ADP molecules, creating two new ATP molecules. The last three steps of glycolysis will remove the remaining phosphates from the two pieces and use them to make more molecules of ATP. Phosphoglycerate mutase begins this final capture of energy by shifting the phosphate from the end of the molecule to a strategic place in the center. The enzyme enolase removes a water molecule, forming a new double bond in an awkward place in the carbon skeleton of the molecule. Pyruvate kinase removes the remaining phosphates and places them in ADP to create new ATP molecules. These pyruvates leave glycolysis and are subsequently burned up completely into carbon dioxide and water.